Be like, oh, well, we already know this.
I like
You like?
triangles.
I like triangles too. Alright, so remember how we've been talking about proofs and writing two-column proofs and how we're allowed to claim like statement reason stuff? Today, we are going to gain two more accessible statements that we can just say with the reason being triangle mid-segment theorem. So if you want to label or give a little like topic section header of triangle mid-segment theorem, that is exactly what we're talking about right now. Now, ruler / straight edge, really I lied, you need a ruler. We're going to make a triangle on your paper. That looks like this. So you can make it as easy or difficult as you want to, but we're going to find the mid-segments of each of those sides. So if I was you, you could make AC 2 inches and then put D at 1 inch. Or make it 4 centimeters and put D at 2 centimeters. Either way, put D and E at the midpoints of those sides. And then connect your A and B to make the base of your triangle. So you're going to draw, it can be any triangle you want it to be, but you're going to draw an AC, and halfway across your AC put a D. You're going to draw a CB, halfway across that, you're going to mark an E. And then I'm going to go shut this because if you did not know, Kobe Bryant passed away over the weekend.
Oh, yeah, my dad was all like, oh my god.
Yeah, my dad too, and I was like,
and I'm like, I don't care.
You guys are the worst people ever. Oh my god. Kobe was
I don't, yeah, and
Yeah, his daughter died too.
my dad kept saying it over and over because he said it was really
Yeah, literally all my dad's
I was
cousins
like,
and stuff were like, he died until it
Hey, so, yes, on the one side of things, you could say it's like, why do we care more about him than any other person? Well, just because he's famous. But on the flip side of that, he did do a lot for, like, the community, and he did, like, give back a lot. So we're going to talk about famous people and, like, should we care? He did do more than the general, I have a boatload of money and I'm more famous than you. He did try to do, you know, good, like, children's outreach and different programs and stuff like that. But they're watching a little, he had a little documentary thing he released. No, it's sad because he was a person out there trying to promote, like, positivity.
Oh, okay.
So when you lose one of those people, it's like when we lose a good teacher, right? Like when a good teacher retires and we're like, man, it's sad because that teacher's not in the classroom anymore. He's not out in the world, like, you know, doing this stuff anymore. Now, so David is doing something interesting here.
Did I do something wrong?
No.
Oh.
You're on your graph paper, you're going orthogonally, right? So if my computer will ever paste.
I looked at
Up,
it.
down, or left, right?
Sounds like orthodox.
Yeah, but like,
Nah.
I thought we were supposed to make it pretty similar to what it had.
Oops.
Now that's the question.
No, I had a picture of it. I think
Okay, my computer's being difficult. Give me a second. It doesn't want to copy paste an image, but if I cut a picture, it'll let me drop it in. So David is doing something like,
Oh, you can
We
totally see
can
the line.
definitely see the triangle.
2, 3, 4,
I
5,
think
6.
so, but I'm not 100% sure.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, now it's red.
No, it's not.
Oh, colorblind, sorry.
Right, midpoint sections.
Oh, okay.
What we're supposed to do is make
So if David drew his orthogonally, it'd be like this. But here's the convenient thing about your paper. You could grab the whole thing and rotate it. Right, so this hypotenuse up here, because David made his like orthogonally, is the base of this triangle. If this is a right triangle. It doesn't matter if it's a right triangle or not, but as long as we have midpoints D and E, we have then this third side that we can call the base, whether we have to rotate it or not.
I read mine like that, so it's easier to think.
Okay. So, if that's what we have, we made ours like that because it's easier, quote unquote. What could we say about DE and AB's relationship?
compare.
They're what? How can we say that?
Because.
I don't disagree, but we have to back it up.
Oh,
I'm just color coding. Just
oh, okay.
red, blue, green. If DE was parallel to AB, what would that create? Corresponding angles. So flip that around. If we have corresponding angles that are congruent, we have parallel lines. Well,
DE is half of AB.
ooh, we'll get there. How can we be sure about these being congruent?
They're congruent to each other. The smaller triangle and the so ACB is congruent to similar to DCB. I think we can do that.
It's side angle side congruency.
Side angle side
Similarity.
similarity, because we know midpoints have created this relationship that CA is twice CD, because that by definition of midpoint, right? And CB is twice CE by definition of midpoint. And blue is equal to blue.
Wait, could I have said angle? Because if we know two angles, then we know the
We don't know the angles yet. We don't know red is congruent to red or green is congruent to green until we know that those lines are parallel. And we don't know that those lines are parallel yet until we see that the triangles are actually congruent. Or, sorry, similar. So, if we know that the triangles are similar, what is a result of similar triangles?
congruent angle.
Congruent angles. Because, you might want to write this down if you wouldn't be able to remember it on a mastery, because on a mastery you'll have to write these things down on your own on a specific problem. Probably not this one. But once we know that this red angle is congruent to that red angle, we then know that AB is parallel to DE. At the same time, and Sophia already said this, we know that triangle ABC is a dilation of 2 times triangle CDE, or DCB, or D. Yeah, if I go in the right order, DCE.
I think we know what
Wait,
you're
so
trying
what
to say.
What I'm triangling to say?
So wait, what you're saying that if we know one of the angles, then we know that the sides are parallel. The lines are parallel.
Hold on. Let me get to a point where I can actually hear your question.
You try and think about this so hard you can't even.
Triangling to.
It's because I wrote them alphabetical order, not the order that I was
Are you
looking.
triangling to hear me?
All right, what were you asking?
So if we know that two angles are, if we know that the triangles are similar, and we know that the angles are congruent, we can prove that the lines are parallel.
So because we know the triangles are similar,
Okay.
we know the angles are congruent.
So those
And because corresponding congruent angles indicate parallel lines, we know parallel lines. Cool. Then because the similarity scale factor is 2, we know AB is twice the length of DE, right? Because we know that triangle DEC is half of ABC, or that ABC is double DEC. So, from here, what this allows us to do is when we're solving proofs, we can now use the triangle mid-segment theorem to say 2 different things. So this is going to be your reason, right? That's going to be your reason column. Please stop helicoptering. It just is a huge indicator of not listening. What are the 2 statements we can use now with that as our reason? Because we just proved them.
That they're similar.
No. I mean, sure, but that's not really that important. That we have parallel sides, and actually we'll have 3 sets of parallels once we actually dig into this. We have similar triangles, but that's like, whatever. The length comparison. When you have a triangle mid-segment, you know that that new segment, DE, is half the length of your base, which can be very convenient depending on what proof we're trying to do. Questions? I'm not going to hit you with a bunch today because you took math, but do me a favor on your paper, and I'm going to show you how to do this. Draw a line. Doesn't matter the angle, but then using your ruler, make another line that's 90 degrees off of it. So use like the tick mark on your ruler to then line up a 90 degrees. Because the tick marks are perpendicular to the edges of the ruler. Right? So use your tick marks to make sure that this comes out to be 90.
Does it matter that?
No, it does not. And then connect your base to be flat. Right? So like with your graph paper. And extend however far you need to. Make a right triangle with the 90 degree not on bottom. Right? The 90 degree should be up on the top. And then we're going to label it as you see here. This gets really, really fun.
I think I might have accidentally made an isosceles. But it,
right.
I think it's a little bit off.
So if this is the triangle that you are all working with, and you drop an altitude, which means it will be perpendicular. We've talked about this before. Altitude means how high you're flying, right? Like what is your altitude? Measured perpendicularly to the ground. That's why an altitude just drops a perpendicular line. So, you've got some classmates, and let's say, I don't know, I get hit by a bus and you end up over at the high school for Math 2.
Oh.
Obviously, you're smarter than the students that would be in the high school Math 2 class. So, you're with them in class. Well, I'm just honest. You're with them in class, and they're arguing with you. And your teacher has said, so all 3 triangles pictured up here are similar to each other. Now, one of the classmates argues there's not 3 triangles. So that's the first thing you have to help those classmates out with. But beyond that, we have to explain to them why all 3 triangles up here are similar to each other. That's your task right now. Once you can justify it to me, we'll move on. But you all have to agree for how can we prove that, or like back up, justify, whatever you want to say, that these 3 triangles are similar. Now, if you want to make your life easy, everybody before we start, if you want to make your life easy, let's call this little c, little b, that's the problem, though.
Because those 2. You could do
little a and little AA.
AA, Ron?
You could do like 2 different types of A's.
I mean, we could do whatever we want, but if you want to avoid A, so that when you talk with each other... Now, little a, though, that's little a. Little a is the whole angle, right, at vertex A. So little a is FG together.
And little a is not degrees.
Little a is 90, right? We know what little a is already. Little a is 90.
We also know that D and E, little d and little e are 90.
Not up to me.
Sophia.
Okay, so I had to do a problem like this on the test, so this is already in my head, unless I did it wrong.
Nah, we believe in you.
Whoa, okay, so let's just look at these 2 angles right now. So you're saying, so we know that G plus F equals 90, right?
Yeah.
So if this is G, this is 90, this is G, then we need the other part of the 90 to equal with this, right?
Oh, I think I get
Yeah,
what
so
you're doing.
then B is equal to F. And yes, and then
would it
so
C
similarly-
equal to G then?
yeah,
That's how it works.
okay. And so we know that B. So now we've proved that these two angles are similar through AAA, and now we also have that and that, which means that we have the same set of angles on the bottom too. Question.
Don't we know that CA is like congruent to on the smaller triangle and the really big triangle?
Yes. So wait,
Feel
what?
free to use highlighters if you need.
So we know that like the mid triangle and the biggest triangle is the CA is the same on both of them. As
So-
like AB is the same on the smallest and the biggest. Just different parts of them.
So we know that that is similar to like that, right? Is what you're saying.
And then the AB is similar to like the smallest triangle and the biggest triangle. Like a leg and the hypotenuse.
Like that. No.
AB.
Sorry.
It's
AB.
never
AB.
mind.
Oh. Yeah, because see, that's a leg.
Yeah.
Okay.
So that'd be.
There's 3 different.
I
It's
know.
confusing because there's
It's
too many triangles.
Just be careful when you say no.
Yeah. Okay.
Too many
That's-
triangles.
No, just, like as a teacher, seriously, one of the biggest things you have to do is like, how is the student thinking about this? It might not be how I'm thinking about this, but that's why I say be careful when you say no.
Yeah. I see how you're thinking. So
Okay.
of the smaller triangle and the
Hey,
smaller
Sophia,
triangle.
color code the 3 triangles.
That's a good idea. Okay.
Maybe he has them once in a while.
Don't tell my wife that.
Same good
It's
ideas.
a joke.
Oh, I get it.
Oh.
So if we call littlest, hold on. If we call littlest triangle blue, medium triangle green, biggest triangle purple, here's where the confusion happened. Each edge there can be looked at in a couple different ways,
Yeah.
right? It might be a leg, it might be a hypotenuse. That's the dangerous part. Sorry, do you want to keep going?
Yeah. Well, I mean, so we proved that they're all similar triangles, right? Because we got angles.
Yeah.
You agree with that? Yeah. Because we have 1, 2. Oops. Yeah, because we have the 1 tick, 2 tick, 1 tick, 2 tick, and then 1 tick, 2 tick.
So if I say write out those similarity ratios, are you comfortable with that, or should I take the pen back?
You can take the pen.
I was hoping I wouldn't have to do anything today, but since you guys math tested, I guess I'll jump in here.
I was hoping I wouldn't have to do it.
Well, that's my hope every day.
I was given like the 2 bottom
As a
lines,
middle school.
and I had to like figure out the length of like CA.
Yeah.
I don't
Let's go short leg to long leg.
Short.
Right?
Which
So-
triangle?
Exactly. If I go short leg to long leg, let's go one triangle at a time.
Yeah.
Short leg here is BD to long leg AD. Right? I'm going little triangle.
Oh,
So
okay.
BD, DA, or AD if I go. So short leg to long leg. Right? Go ahead and write that down, please. As long as your points are labeled same as mine. If I then go short leg to long leg of the medium triangle, that's green. So short leg is AD to long leg DC, right? Because green triangle. Then on purple triangle, short leg is,
Purple. Okay.
yeah, AD
And then
short leg.
C.
and AC, right? Because now my hypotenuse is actually on the bottom,
Wait.
right?
AB
it's kind of weird.
is the shorter leg. AC is the longer leg
Of the purple triangle.
of the purple triangle.
But, like, we're not involving hypotenuse here. You with me?
Yeah.
Now, BD is part of BC. Okay. We can write down a few more things like this, right? If we...
Wait, what are we trying to do you want?
I don't know.
Just do whatever.
Just trust me. Which I know is a difficult task, but we did short leg to long leg, right? Let's do short leg to hypotenuse. So short leg, so BD, AD, and AC. I'm going to go ahead and write all these down. BD on top, AD, short leg, AB.
So we're doing short leg and hypotenuse.
So that's AB then, right?
AB. And then
AD short leg to hypotenuse.
AC.
AC, yeah. Short leg,
Right.
AB to hypotenuse, CB, right?
Yeah. There's too many triangles. It gets confusing. We're doing short leg and hypotenuse.
We're just setting up equivalent ratios, right? Because scale factor, we know that these are similar. We've proven it because angle, angle, angle. What haven't we done? Long leg to hypotenuse?
Oh, I see where you're.
So if we go long, I'm going to grab the bottom of all these because those are all my long legs. AD, DC, and AC. Those are my long legs. Long leg AD compared to AB. Long leg DC to hypotenuse AC.
If those were flipped, it'd be better.
Huh?
If you did like the. If
AC
it was AC or DC.
to CB or BC, right? Oh, this? CD?
If it was AC over DC.
Oh, yeah. Man, how in the world does this relate to the...
What are we trying to do?
Figure
I
out,
know.
figure out how the Pythagorean theorem actually exists.
Because
So-
the Pythagorean theorem is like when it.
So hold on. Think back to the days of Pythagoras, because then I'll let you like run down whatever road you want.
Oh.
In the days of Pythagoras, they didn't have the Pythagorean theorem until they formalized it. We are trying to figure out how they got there. Hang on to it for a second. I know, don't let the cat out of the bag yet. So, first off, who put a cat in the bag? So, we know these things about angles, right? We have these agreed upon rules about triangles and the angles that create them and that they all equal 180 degrees. All of that's fine. And we agree with all of this, right? These similar ratios. That's a good question.
Oh, it is.
All of them are right triangles. That's why I like them.
You guys notice anything interesting about those ratios?
They all
Like each
use the
set?
same words. Can you like?
Do stuff with that?
Yeah. Like,
Wait a minute.
like the blah blah blah.
So like.
If we're trying to prove the Pythagorean theorem.
They're all equal to question.
Sophia?
Or, well, like, couldn't you, like, get them not in ratio form and then just have a bunch and then simplify that down, or would that be the wrong way?
I mean, sure. What do you mean not in ratio form?
Well,
What can we always do with ratios?
you can mix them up.
We can always cross multiply, and we could switch around their orders, right? Go ahead.
So like with the purple one, it's like AD over DC equals AB over AC, and then on the green one, it's like if you do the top of those two, it'd be AD over AB, and then the bottom two, DC over AC. Like they're kind of cool.
Oh, so wait. You are maybe I misheard you, but are you relating that we have AD here and here?
Well, no. But
Sorry,
yes.
there's a lot of letters here
Yes,
that I couldn't
but
quite hear what you
no.
were saying.
So, here, like, these two are right there, and then these two are right there. I don't know. I just noticed
Well,
that those two.
My brain likes to find matches, so this is my brain, which this could be wrong. This could be totally wrong. But my brain, that's what my brain saw, right? When I said, what's up with these ratios?
No.
I don't know, though.
Whoa, look at that. Well, they're all in a different pattern.
Oh.
The first one, then the second
And then,
one,
like,
the first
the-
one, then the last one, then the second one, then the last
80, and then 80, 80, 80.
one.
They are similar, but similar.
Because
I don't know what I'm trying to say at this point.
So wait. If I follow this, AD squared, right, because AD times AD equals BD times DC, right?
A, D.
Yeah, BD times DC, right?
Yes.
If I come down here, AB squared
Yeah.
equals BD times CB, right? Because BD, CB,
In
and
the top one you have 4 D's.
Wait a
And then
minute.
in this bottom left one you have 4 B's. And then I'm guessing in this one you're gonna have 4 C's. So in each one of those you have 4 of a letter. Except A. You have 4 of D in the top, 4 of B in the left, and then 4 of C in the bottom right. 4 A. Oh, A is in the beginning of each of the squared ones,
DC.
but nowhere else in the other.
Oh, cross multiply.
If you just look at the squared part, you have A in the first, and then some other letter or something. I don't know.
yeah, I mean, I agree.
You just have the square DC.
You divide everything by C.
You what?
In the green one, you divide everything by C.
A squared equals D times B.
Oh, there's 4 C's in the bottom right, there's 4 B's in the bottom left, and 4 D's in the top right.
You mean 3? Wait, what?
So it's squared, so there's 2 of these, and then these 2.
Okay.
There's a 2, and these 2.
Got it.
And then
Well,
2 of
now
these.
remember, those are lengths.
Yeah,
So that's really like one.
What if
Right.
you sign?
Yes, but
I've
no.
just been
It's something.
You what?
So I've just been kind of trying to reword them, but I assigned a variable to each of them so it's a bit easier to see.
Yeah, like ZKF or something, like, you know, like some other nonsense variables we haven't been using.
Then I mess everything up. Just like when you put T.
Yeah, interesting.
So interesting, you dropped your pen.
Yeah, because gravity.
Gravity, silver.
Oh, you're done?
No.
Oh.
That's mine.
You have proof of what?
Gravity is fake.
No, that is nope, not what we're doing right now. So, hold on, if I look at my purple triangle, the hypotenuse is CB. But nowhere do we have CB squared. If I look at my blue triangle, I have AB as the hypotenuse, and I have AB squared here. So my hypotenuse squared equals BD. Okay, so that's from that little triangle. C.
Wait,
This isn't from the little triangle, though. Crud.
Oh, never
Are
mind.
you trying to think that they'd all be from the same triangle?
No, I thought that there are 2 B's in that, so it's like D.
But wait, isn't CB BD plus DC?
CB is equal to CB plus B.
Yeah.
That was different.
Yeah, couldn't I break up CB and write it as DB plus DC?
Yeah.
Because CB is the sum of the segments.
It's not me. It's not me.
Take a moment and think, guys. What could we do? How can this back up our Pythagorean theorem.
Pythagorean, what are you doing? Wait, okay,
I
so
think we have like 3 minutes left, by the way.
I know.
Pythagorean, what
Totally
why-
time to work on homework.
Wait, we have AB squared equals, where's BD though? BD. Oh! Okay, look. BD,
What?
and then there's another BD, and then there's a CD, right?
I'm-
We split that up. BD, and then
I
another
heard you
BD.
say CT and I'm like this.
No, okay, and then there's another DB, right?
I'm very confused.
There's another CD. Right? Okay, so we can just say BD squared. Oops, shoot, wait, did I say the wrong thing? Hold up. Now I'm confused. Hold on. I feel like I'm close. Hold on. It's all the things. Oh my goodness. Well, never mind.
Forget about AD. Forget about AD. We made that, right? We made AD. Forget about it. AB's a leg, right? AC's a leg, right? We have AB and AC, right?
Yeah.
Oh, so if the Pythagorean theorem's true, then we can say, well, we don't know it yet, right? We haven't proven it yet, that AB squared plus AC squared.
Equals AD squared.
No, we don't know that yet. But what we do know is BD CB plus DC plus B or times BC.
Holy snap. That looks.
This is too much for a day where we've already had
Wait.
like over an
Athena's
hour.
saying something.
Is that under the C or under the? It's under the C, right?
This is
That's squared.
this is when you know you have
You
too many
can square
variables
those two,
or letters in math.
right? So CB squared. What just happened?
For the past half an hour, we've just been doing math just with letters, and it's a little.
Wait,
I
what?
factored CB.
Oh, because there's a B and a C and a C.
Stick with me. We're over time. Like, not actually over your time, but over when we shoot to get out of here. I factored CB out.
No,
What's
we
BD plus
actually
DC?
leave it 11. Because that's
What's-
CD is columns.
Hey, what's BD plus DC?
BD.
This is CB,
Holy snap.
right?
Oh!
BD plus DC is CB.
So then you got CB squared.
Holy snap.
So then leg squared plus other leg squared equals hypotenuse squared. This
Oh my.
is the proof of the Pythagorean theorem.
Love
Okay.
Guys, we are as good as Pythagoras.
Really?
You might as well put a pentagram on your hand and become a Pythagorean.
No.
You not know that? So, seriously, the Pythagoreans, the symbol of the Pythagoreans was a pentagram, which was not only a 5-sided star, but also had tons of triangles inside of it. And I'm not sure if it was true that they like had the symbol like on their hands or whatever. But seriously, the pentagram was the symbol of the
When we
Pythagoreans.
first learned about
So, tomorrow, we will continue trying to be better than Pythagoras.
imagine like
Have a great day, guys.
imagine like when a kid first learning